Hello, students. Previously, we learned about Tangram recognition and puzzle assembly principles. Today, we will explain the Tangram creative shape assembly experiment using machine vision software. Now, let's enter the classroom and learn the steps for Tangram creative shape assembly together. This lesson mainly includes the following contents. It is hoped that through studying this lesson, you'll be able to achieve the following learning objectives. First, you need to open the MV Viewer software and acquire an image. Open the MV Viewer software and acquire an image. Adjust the parameters in the common parameter options to obtain a clear image. After acquiring a clear image, close the MV Viewer software. Open the Kimage software to perform the Tangram creative shape assembly operation. Create a tool group named Endpoint Calibration. For tasks involving positioning and sorting, the Endpoint Calibration tool is generally used. Double-click to open the tool group. Add a PLC control tool. Double-click to open its parameter interface. Check the Homing Settings option. Click the Unbind, Execute button. Add a Light Source Control tool. Double-click to open its parameter interface. Set the value for the backlight panel. Add a camera tool. Install the calibration board on the motion platform. Move the motion platform using the control joystick while clicking the camera tool's Run button to view the captured image until the camera captures the large circle and the letter K on the calibration board. Double-click to open the PLC control tool. On the parameter setting page, click Control Settings, Get Position, Unbind, Execute. Then recheck the Motion Settings option. Copy the X-axis and Y-axis position data from the axis position page and paste them into the X and Y position fields under Motion Settings. Add a Find Feature Points tool. Right-click the mouse, select Auto Reference. Draw a selection box around 4 circles. Double-click to enter the tool's basic parameters page. Modify the parameters. Click Run, and P0, P1, P2, P3 will automatically appear on the 4 circles. Add an Endpoint Calibration tool. Double-click to enter its basic parameters interface. For the pixel coordinates field, reference the output parameter key points from the Find Feature Points tool. For the world coordinates field, select Multi-Point Update and the pixel coordinates of the 4 circle centers will appear. Add a PLC control tool. Double-click to enter its basic parameters interface. Appropriately set the Z-axis position value so that the suction nozzle mechanism descends to a position where it can touch the Tangram piece. Then move horizontally to the positions of the 4 circle centers. Copy the X and Y coordinates of the 4 centers obtained by the PLC control tool into the world coordinates X and Y fields of the Endpoint Calibration tool. Click Execute. Click the Parameters page, Output Parameters, to check if there are any issues. Note, when the sum of the X direction pixel equivalent and the Y direction pixel equivalent is within plus or minus 0.01, it indicates that the positions of the 4 circle centers entered are accurate. It can be seen that the X direction pixel equivalent has a problem at this time. Return to the Basic Parameters page and check. It is found that the X-axis positions of the P2 and P3 circle centers were entered in reverse. Correct this. Click Execute. Now the values of the 2 pixel equivalents are normal. After setting, click Homing Settings, Clear Interrupt, Execute. Then delete the PLC control tool. At this point, the endpoint calibration task is completed. Next, we begin the Tangram assembly task. Add a module named Tangram Assembly. Click to enter the module main interface. Add a tool group named Image Capture. Double-click to open the tool group. Add a PLC control tool. This tool is the same as the one in the Endpoint Calibration tool group. You can return to the Endpoint Calibration tool group, copy the tool to the Image Capture tool group in the Tangram Assembly module, and rename it Capture Position. Add a light source control tool, a camera tool, a timer tool, and another light source control tool. Open the parameter interface of the light source control tool and set the backlight panel value. Open the parameter interface of the camera tool. Under Calibration Data, select Endpoint Calibration. Open the parameter interface of the timer tool and set the delay time. Remove the calibration board and replace it with arranged Tangram pieces. Run the program once. If you find the image in the display window is overexposed, you can open the camera tool's parameter interface and adjust the exposure value. The Image Capture tool group setup is complete. Add a tool group named Image Acquisition and Positioning. Double-click to open the tool group. Add 2 color extraction tools and 2 image processing tools. Rename the first color extraction tool Blue Extraction and the second one Cyan Extraction. Rename the first image processing tool Blue and the second one Cyan. Double-click to open the parameter interface of the Blue Extraction tool. In the Tool Reference drop-down list, click the Input Image button and select to reference the output image from the camera tool in the Image Capture tool group. Return to the parameter interface. Click Register Image. Delete the original ROI region. Next, you need to adjust the RGB thresholds. Find the maximum and minimum values for R, G, and B. When the mouse moves over the Tangram piece, the values for R, G, and B will be displayed in real time below the display window. Therefore, move the mouse over the blue Tangram piece to find the max and min values for the 3 channels. Fill them into the red, blue, and green input boxes of the Blue Extraction tool. Click Execute. Select Binary Image in the Output Mode column. Click Execute. It can be seen that part of the blue Tangram piece was not successfully extracted. You can click Register Image. Move the mouse to that area. Adjust the max and min values for R, G, B based on the real data until the entire blue Tangram piece's color is extracted. Double-click to open the Blue Image Processing tool. Select Closing under the Recognition Mode column. In the Tool Reference drop-down list, click the Input Image button and select to reference the output image from the Blue Extraction tool in the Image Acquisition and Positioning tool group. Click Execute. Next, process the Cyan Tangram piece. The steps are the same as for the blue Tangram piece. Note: at this point, two triangles appear in the image, which will interfere with the subsequent shape matching process. Continue adjusting the threshold until the unwanted Tangram piece no longer forms a recognizable shape. Then add two shape matching tools. Rename the first one Blue Triangle Positioning and the second one Cyan Triangle Positioning. Double-click to open the parameter interface of the Blue Triangle Positioning tool. First, clear the options under Tool Binding, then click the Input Image button and select to reference the output image from the Blue Image Processing tool in the Image Acquisition and Positioning tool group. Click Register Image, then drag the Module Region box in the Image Display window to frame the target triangle. Click Set Center, Create Template, Execute. The center of the recognized template is slightly biased to the right. Later, when the suction cup picks up the Tangram piece, it might detach due to unbalanced center of gravity. Delete the template and recreate a suitable one. So that the template center is biased to the left. Adjust the parameters of the Blue Triangle Positioning tool according to the actual situation. Among them, a lower value in the template score column indicates that the shape is easier to locate. Modify this template name to Blue Triangle. Click Execute. Use the same method to establish the Cyan Triangle Positioning. At this point, the process setup for the Image Acquisition and Positioning tool group is complete. Next, add a tool group named Puzzle Positioning. Double-click to open the tool group. Then add 3 image display windows to place the processing results that need to be displayed. Drag the Blue Triangle Positioning tool from the Image Acquisition and Positioning tool group to the first window and the Cyan Triangle Positioning tool to the second window. Drag the Camera tool from the Image Capture tool group to the third window. Drag the Puzzle Positioning tool group to the fourth window. Open the Puzzle Positioning tool group. Add a Puzzle Positioning tool. Double-click to open its parameter interface. In the Input Parameters list, find the Position item. Double-click to open its Variable Attribute interface and add a row on the list page. Do the same for the Angle and Shape Type items. Set the reference data for position. Position 0 references the variable assignment path, Image Acquisition and Localization Blue Triangle Localization Output Parameter Monitoring Point. Position 1 references the variable assignment path, Image Acquisition and Localization Cyan Triangle Localization Output Parameter Monitoring Point. Set the reference data for Angle. Angle 1 references the variable assignment path, Image Acquisition and Localization Cyan Triangle Localization Output Parameter Target Angle. Set the reference data for Shape Type. Shape Type 0 references the variable assignment path, Image Acquisition and Localization Blue Triangle Localization Input Parameter Template Name. Shape Type 1 references the variable assignment path, Image Acquisition and Localization Blue Triangle Localization Input Parameter Template Name. Click Execute. The system reports an error. The error message indicates that the base position does not match the input position variable parameters. Troubleshoot the cause. Two reasons were found. First, you need to click Set Position, Execute on the Parameters Setting page. Second, an angle conversion is needed. On the Parameters page, find the angle item, reference a calculator, and input the content. Create another tool group named Pick and Place. Puzzle positioning must be completed correctly before sorting can proceed. Double-click to open the tool group. Add a User Variables tool. Add 4 PLC-controlled tools, named Pick, Lift, Place, Lift, respectively. Open the parameter interface of the User Variables tool. Double-click the Output Parameters option on the Parameters page to enter the Edit interface. Set the output parameter types. Select Type 13.F list from the list. Rename it Pick Position. Click Add. Use the same method to add Place Position. For Angle, select Type 3 Double List. Rename it Angle. Click Add. Return to the Parameters page. Add a data position for both the Pick Position and Place Position options under Output Parameters. Pick Position references the input parameter position from the Tangram Assembly Module Puzzle Positioning Tool Group Puzzle Positioning Tool. Place Position references the output parameter position converted from the Puzzle Positioning Tool. Angle references the input parameter angle converted from the Tangram Assembly Module Puzzle Positioning Tool Group Puzzle Positioning Tool. Click Execute. Note: Pick Position still needs conversion. Check Variable Index. Check Pick Position. Select Destination Type, .F. Click the plus sign to add. Process Place Position using the same method. Angle also needs processing, but select its destination type as double. Click the plus sign to add. First, disconnect the link between tool groups 2 and 3. Create a new loop tool group and connect it to tool group 2. Open the loop tool group settings, change the 7 loop break condition to true, change the 4 for loop end value to 2. Then move the Pick and Place tool group inside the loop tool group. Double-click to open the loop tool group. Set the Pick and Place tool group as the Start module. Double-click to open the Pick and Place tool group. Double-click to open the parameter interface of the User Variables tool. For the input parameter conversion index, reference the current loop count from the loop tool group's parameter options. Click Execute. Next, set the X, Y, Z-axis positions for the Pick tool, Lift tool, Place tool, and Lift tool. The Lift tool's position only involves the Z-axis, so by default set the Z-axis to 0, meaning Z-axis homing. Double-click to open the parameter interface of the Pick tool. For the X-axis position in the Motion Settings section, follow the navigation sequence. Variable assignment page grabbing and placing tool user variables output parameter. Convert, .F. Grabbing position. Sequence, number X option. Set the variable referenced by the Y-axis position using the method above. Then set the Z-axis value. First, uncheck the X and Y-axis. Set the Z-axis value according to the actual situation. Set it to the height where the suction nozzle just touches the surface of the Tangram piece. Recheck the X and Y axes. Check this suction nozzle open vacuum option. Double-click to open the parameter interface of the first lift tool. Check the R-axis and its position needs to reference variable assignment page grasp and place tool user variables output parameter. Conversion, point F. Grasp position, sequence number option. Double-click to open the parameter interface of the place tool. Click this suction nozzle close vacuum option. Check the Z-axis. Its position value should be the same as the Z-axis value in the pick tool. For the X-axis position, follow the navigation sequence. Variable assignment page loop user variables output parameter. Conversion, placement, sequence number X option. For the second lift tool, set the Z-axis to 0. At this point, the setup of the entire program is complete. Return to the main interface of the Tangram assembly module. Add a homing tool group named Return to Origin. Double-click to open the tool group. Add a PLC control tool. Double-click to open its parameter interface. Check the homing settings option. Click the Unbind, Execute button. If the homing tool is not added, it will remain at the last position. Save the configuration file. Run the program to see the effect. All right, students, the above are all the operational steps for the Tangram sorting and puzzle experiment. After class, students should practice more to consolidate the knowledge learned in this lesson. Thank you for listening. See you in the next class.